with a subtopic of analytical geometry. Now, when we are looking at intersecting circles, there are many types of intersecting circles that we need to look at. When circles touch internally, when they touch externally, when they intersect. So first we need to understand what is a concentric circle, right? What are concentric circles? Where one circle is basically inside another circle, but they share the same center. So circles that share the same center are called concentric. Example, like this, right? They share this exact same center. Right, so so concentric circles are circles that share the same center, right? And great. Let's move on to when circles touch internally and externally and stuff, right? So what is when circles touch internally? When they touch internally, we get a diagram like this. That's one circle and draw another circle here. So we'll take the big circle with the radius r and small circle with the radius small r. So in other words, they kind of have like a common tangent. So let's see, touch internally. Let's call this center A, right? And this is center B. So the distance between the centers, there's two important things. You have to find the distance between the centers, right? And look at capital R, and the big radius is from here to there, to the end, from the center to the circumference. And the small radius is this small portion over here. Remember the portion from B to the common tangent point. Now, remember when circles touch internally, it also has like a common tangent, right? There are two cases when circles have a common tangent. Now, look at the distance, the yellow distance is capital R. That's a big radius. And for the small radius, I will use this green distance over here, right? That's also R, right, from the center of the circle, provided it's drawn from the center of the circle. Now you can clearly see the distance AB. The distance AB is basically equal to capital R minus small r. So when this condition holds, the circles will touch internally. Let's look at what is touching externally. When do the circles touch externally? So what's important is we need the two radius. We need the two radii, the big radii and the small radii, and we need the two centers. So make sure your equation of circles is in center radius form. If you send center radius form, then we can read off the big R and the small r. Let's look at externally. So we have a capital R, all right, and so externally is quite simple to see. Right, so this is center A, right? And the next one is center B, right? Circle centers. And the distance between them is AB, the distance AB, right? The distance AB can just be calculated as capital R plus R, right? Can be calculated as, this is capital R and the small r. So if I add the capital R plus small r, we'll get the distance AB. Right. So if this condition holds, then the circles will touch externally. And we also get a common tangent here. Where's a common tangent? There's a common tangent here. Now the common tangent doesn't need to be a vertical. The common tangents is just basically, it doesn't need to be a vertical line. It's just that I'm drawing the circle like this. That's why I'm drawing vertical line here. Common tangent is just an equation. Common tangents has an equation which is y equals mx plus c. Even this one here has y equals mx plus c. That's what we call a common tangent, right? It has that equation. It doesn't need to be like this. It can be in any angle. It's just that because I'm drawing the diagram like this, it shows a vertical line. Right, so what we did internally and externally. Next is when the circles intersect, right? When do they intersect? So looking at intersecting circles. Intersecting circles is, we have two circles, but they intersect, right? In other words, the equations of two circles, but they intersect. So if they intersect, we have A here, and just say this is point B there, right? And now the thing about intersecting circles is that you got to go and take the difference and the sum. Now you have to look at all the possible scenarios of circles, what can happen, right? So that's what we are doing now. We're giving you all the rules for what can happen. So capital R is a distance from here to there, right? And small r is the distance from the center to the purple circle, right? So we say we calculate r minus r. The rule is we need to check this out. Then it will always intersect at 2 points, right? So you have intersecting circles. It intersects at 2 points. So what we have here is capital R minus R, right? It must be the distance AB, the distance between A and B must be between R minus R and R plus R. Okay, why we say it must be in between? Because look at the circle here. Uh, Obviously, this is like a minimum distance and that's a maximum distance, right? So in order for them to intersect at 2 points, you just need to move that circle a little bit on the inside, then it can. So you just need to move it just less than R plus R or greater than R minus R. That's the reason why we say it intersects if the difference of the radii, if the distance AB, the distance between the two centers is between the difference of the radii and the sum of the radii, okay? That's the intersecting circle, a very important concept. Now, in an intersecting circle, we get something very important. We get something called a common chord. Where's a common chord? We don't get a common tangent now. This is a chord. This chord is common to both the circles, and it has the equation y equals mx plus b. Y equals mx plus c, right? So what we get is a common chord. So remember in the first two we had common tangent, and over here we got a common chord. Equation of the common chord you only get in intersecting circles, and it intersects at 2 points. This is a common chord. All right. So far in intersecting circle, well, the first one is just basic knowledge. We got 1, 2, 3, right? 3 inequalities. Well, 2 equations, 1 inequality. Now there are 2 more cases, right? When the circles touch externally, they do not touch at all. So what is it? Do not touch. So circles do not intersect, right? The first one is very simple because that's clearly visible, but I will show you another one where they do not intersect, right? So when the circles do not intersect, they can do not intersect on the outside and on the inside. Now let's have a look at what's on the outside when they do not intersect. In other words, they are mutually exclusive. Remember that word from, right? Probability. But anyways, we say disjoint, right? So now this is circle A, circle center A, and circle center B. That's why you can call it circle A and B. Now, the distance between the centers from A to B, you can clearly see if the distance from A to B is bigger than the sum of the radii, right? You can clearly see if this is R1 and that's R2, you can clearly see that this is an extra length here, right? So AB is clearly bigger than R plus R. So if this happens, they do not intersect. Now there's another case when they do not intersect. When we have a circle and we have another circle on the inside, but they do not intersect at all. See, you have like a smaller circle on the inside. So this is the two centers, right? So now these are all the possible cases. This is A, that is center A, right? And this is center B. And the distance between the centers is basically this. Okay. So we say AB. So now in this case, we just say AB is less than R minus R. Okay. Sorry, the other way around. AB is greater than R minus R. Right. So let's look at this. So your R is from A to the end, and this R is from there to there. Okay. There's an issue. This here should be less than, I think. Wait, AB is okay. So we are trying to allocate this point over here. So capital R is this entire distance here, and we are subtracting this R over here. Capital R. So AB will be less than R minus R. AB will be less than R minus R. Okay. So in other words, basically it's out of this boundary. AB is greater than R plus R, and AB is less than R minus R. Yeah. So if it's out of these boundaries, then we have, yeah, so I can kind of like draw a diagram here. So we have this point as R minus R, and we have this point as R plus R, right? So your summary. Now, when it's R minus R over here is internal, touch internally, right? When it's R plus R, it's also touch externally, right? And when it's in between, it's intersecting. When AB is less than R minus R, they do not intersect. So basically is on the inside, the circle is on the inside. So do not intersect. And same here, do not intersect. So it's an easy diagram, right? Yeah, so anything more than R plus R, you kind of like dealing with the outside. that's on the intersecting, and anything less than r minus r, you're dealing on the inside. So on the that's internal touch. Right. So we know the 5 different types of circles: 1, 2, 3, 4, 5. Right. So there are 5 different types of intersecting circles. Now let's solve some problems based on this. Right. So we have x minus 2 all squared. So we can see this is the bigger circle because it has a bigger radius, right? And there's a smaller circle. So you take capital R and R. So we can see the center is 2 and -1, and capital R is 3. Over here, let's call it A and B, all right? A and B is -1 and 3, and small r is 2. Right, so now we have A and we have B. So we need to find the distance AB. Distance AB will be the square root of y2 minus y1, which is 3 minus -1, and x2 minus x1, -1 minus 2, which is equals to now 5, right? And we want to find r plus r, which is 3 plus 2, which is also 5. So this implies AB is equal to r plus r. So both the identities are equivalent. So circles touch externally. Okay. Circles, they touch externally. Now remember, if they touch externally, they touch at a single point. That's why we have a common tangent. Yeah, by the way, sometimes they ask you for the equation of the common tangent. To find the equation of the common tangent, you need to solve this equation simultaneously. Or you can find, yeah, we will come across those types of questions. Yeah, but you can solve them simultaneously. Take equation 1 minus equation 2, and you'll just get an equation in terms of x and y. Right? So it's best to put the equations in center radius form. So you can solve it quick. If you don't know how to put the equation in center radius form, showed you how to complete the square. So the coordinate of A over here, or you can call it center 1 and radius, all right? So the center 1 is -4 and 5, and the radius is 5, because square root of 25. And center 2 is -4 and 2, and the radius is 4. Right, now what is the distance between the centers, which is C1, C2, which is equals to the square root of -4, -4, -4, -4. So that's -4 plus 4, which is basically 0, plus 2 minus 5 squared, 2 minus 5 squared. So that's just going to give us 3, right? And now I want to find r plus no, I think I can just find r minus r because I have a nice exact value. So I can just say r minus r. So that's 5 minus 4, which is equals to 1. Okay, that's not good enough. And now I need to find r plus r. R plus r is 5 plus 4, which is 9. So the value of 3 is between 1 and 9. So they intersect, right? So you can say r minus r is less than 3, which is less than C1, C2 distance between the centers, which is less than R plus R. So what we can say here is the value of 3 is between 1 and 9. So they intersect. Circles intersect at 2 points. Don't just say circles intersect. It basically, you can't, because this is also intersecting, but at a single point. That's why we say they touch externally. Over here, circles intersect at 2 points. Just say 2 points, right? Circles intersecting at a single point is either internally or externally. Right, so that's a nice question as well. And then last one. See now, for the last one, full equations are given, all right? Because full equations are given, we need to complete the square and then find the center and the radius. So a little bit of work to be done there, but it's easy because you just need to complete squares, right? So let's complete the square for this first one. We got x squared plus y squared. So x squared minus 6x plus minus 6 divided by 2 squared plus y squared plus 8y plus 8 divided by 2 squared is equal to, there's no numbers here, so is equal to, take the same thing, square it, add it on the other side, minus 6 over 2 squared plus 8 over 2 squared. Now simplify, we got minus 6 divided by 2 is minus 3, and we have y here, 8 divided by 2 is plus 4, right? And this is 9 plus 16, which is going to give us 25. You can see the center is 3 and negative 4, and the radius is 5. That's only for the first part. What about the second part? The second part is this, and we need to simplify this. And so we got the center and the radius. Now, next part is x squared plus 4x plus 4 divided by 2 squared plus y squared minus 6y plus minus 6 divided by 2 squared is equal to 12 plus 4 over 2 squared plus minus 6 divided by 2 squared. Now we have x plus 2 squared, because 4 divided by 2 is 2, plus y minus 3 squared is equal to 12 plus 4 plus 9. That is also, that's also 16 plus 9, which is 25, right? And we got center 2, which is negative 2 and 3, and a radius is equal to 5. 3 and negative 4, radius 5. All right, so if you try to find the distance between the centers, C1, C2, we will get minus 2. That's y2, all right? Sorry, x2 minus x1, minus 2 minus 3 squared plus 3 plus 4 squared. I want to double check this. This is minus 2 minus 3 squared plus 3 plus 4. 3 minus minus 4, yeah. So that's going to give me 25 plus 49. That's going to give me a square root of 74. 5 and 9, yeah. And if I try to find r minus r, I will get r minus r, which is 5 minus 5, because both the radii is the same, is 0. And if I try to find r, I will get r minus r, which is 5 minus 5 because both the radii is the same, is 0. And if I try to find r plus r, I will get r plus 5, which is 5 minus 5. And if I try to find r plus r, I will get r minus r, which is 5 minus 5 because both the radii is the same, is 0. And if I try to find r plus r, I will get r plus r, which is 5 minus 5 because I'm going to get 5 plus 5, which is 10. So what we see here is, are they intersecting? Yeah, they're intersecting because the value of square root of 74 lies between 0 and 10. So remember, 0, square root of 74, it lies between 0 and 10. So in other words, r minus r, 74 is less than, let's take the 74 out, put C1, C2, the distance between the centers, and r plus r. So intersect at 2 points. Right, so that's how we will solve these types of problems. All right, guys. Now I want to go back to our papers that we are doing and solve some examples because now we have a little bit more insight. So remember we did this problem yesterday. Determine the two circles centered at M and N will intersect, touch externally, or do not intersect at all. All right. So yeah, so just doing that question again. I just want to go back and do that question again. Where's this? So radius 1 was root 10 and radius, this next one was, uh, so this was a question. So we had circle M and circle N. So the coordinates of M was 2 and -5, and the coordinates of N was 5 and -8, right? The radius, okay, so this is a smaller circle, so I'll call it small r, M. Small r was root 10, right? And the big R was the bigger circle, which is 2 root 10. That's what we had. Now, we find the distance between the two centers, which is MN, which is equals to square root of 5 minus 2 squared plus minus 8 minus 5. So minus 8 plus 5 squared. Right, just using the distance formula, straightforward. So that will give us square root of, what's 5 minus 2? That's 3 squared is 9 plus, again, minus 3 squared, which is 9. All right. Square root of 18. So 3 root 2. Okay. That's 3 root 2. Now we want to find the difference, r minus r. Remember, three different quantities we need to find. R minus r is 2 root 10 minus 10, which is just root 10. And the third one is r plus r is equal to 3 root 10 because 2 root 10 plus root 10. Now you can clearly see 3 root 2 is between root 10 because this is root 10 and this is root 90 and this is root 18. You can clearly see root 10, 3 root 2. The value, the distance between the centers lies between this, right? And 3 root 10. You can compare, if you're doing comparison, that's square root of 18 and the square root of 90. So this implies is r minus r less than mn less than r plus r. Therefore, circles intersect at 2 points, right? So that's how I would solve this problem. Now let's continue with the rest of the past paper problems. And I think that was a Northern Cape paper, analytical. Yeah, it was analytical geometry, this question here. Okay, so we're doing well with solving problems, right? Let's look at the next analytical, right? Okay, this part is just gone in Afrikaans. So I'm not gonna answer this, right? I'm just trying to understand that you've got point C here, which is the tangent. Point D, which is the center of the kind of like understand what's the middle point. That's the center of the bigger circle. CA is what is CA? CA, I think, is a tangent, and it crosses the x-axis at A. And CDE, CDE, middle line is basically the diameter of the bigger circle. If it's given that this is the small circle, C and D, I think they want the coordinates of D. Gradient of OC. I think we can answer this question. It's fine if it's in Afrikaans. Yeah, try to make sense of it, right? No issues. Vishwa, do you know what they're asking us for? The first question. Give the radius. Isn't here radius? Radius. This asking for the radius, right?
So I think it says give a reason why points O, C, and D lie on a straight line.
Okay, thank you. Give a reason why point C and okay. Uh, mm, because isn't they said it's a diameter? This they told us that CA is CD is the thing of the bigger circle. It's a diameter, and that's a tangent. Tangent and diameter. The reason why point C and D lie on the straight line. Diameter. It's a diameter, 4.1. CD is the diameter of the circle. Is a diameter. Okay, I'm just going to write this for now because there's no use solving this problem, right? I don't even understand this thing fully. Let's look at the second question. All right, so now we know that this is 90 as well, all right? Right, so the second question they're asking us for is gradient of OC. We can see the word gradient there, right? So they're asking us for the gradient of OC. Now, remember, we have done a problem like this. Gradient of OC, we can see O is 0, 0, and C is 1 and -2. So gradient of OC will be y2 minus y1 minus 2 minus 0 divided by x2 minus x1, 1 minus 0. Right, so it just be -2. Okay. Uh, show how to get t equals 3. I think that's what they're asking us for, right? So how to get t is equal to 3. Sorry guys, 4.1. What, how is CDE? Is CDE, CDE is the diameter. They ask, give a reason why OC and D lie on the straight line. OC and D. That's incorrect. 4.1. Let's go back. This is supposed to be OCD. I was looking at CDE, right? 4.1. We need to say OC. We need to say OC is perpendicular to AC. That didn't make sense at all. Why is CD? You can't just write CD is the diameter. OC is perpendicular to OC is perpendicular to AC because that's a radius perpendicular to tangent, right? And then you also have DC. So see what I'm doing here now. I'm going to join this line here, right? I'm doing radius perpendicular to tangent. So now obviously that part is 90. And guess what? You said DC is perpendicular to AC as well. DC is also perpendicular to AC. And that's another radius perpendicular to tangent. So now OCD is a straight line, isn't OCD? OCD is a straight line because you got supplementary angles. You got 90 plus 90. So this implies you got angle C1 equal to angle C2. This implies angle C1 uh, plus angle C2 is equal to 180 degrees, right? Uh, Supplementary angles equal supplementary angles, right? Because supplementary angles. So this implies, therefore, OCD is a straight line. OCD is a straight line. This is more logical proof, okay? Sorry about that. I was looking at CDE. Right, so it can't be straightforward like reading off from there. So this is the proper reasoning. Now, the gradient of OC was -2. Okay, we sorted with that. They wanted to show that we needed to show that T is equal to 3. Now, T is equal to 3 is collinear points, all right? So because the gradient of OC must be the same as gradient of CD. Gradient of OC must be equal to gradient of CD, right? Because of collinear points. Or you can say collinearity, collinear points. Now, collinear points, so what is the gradient of CD? You know how to find the gradient of CD, which is -6 minus -2. So -6 plus 2 divided by T minus 1. And that must be equal to -2. I can cross multiply and solve this equation. So I've got -2T plus 2 is equal to 1 times -4 is -4. -2T is -6. Therefore, T is equal to 3. So we have solved this. Okay. We want to find the equation of AC. We want to find the equation of AC. Let's take this diagram down. Right, so let's find the equation of AC. To find the equation of AC, we need the gradient of AC, all right? So we need to say the gradient of AC is equal to the keep change flip, so basically the flip of this gradient with the opposite sign. So minus half, no, half, because -2 times half will give me -1. So it's gonna be half, and it's upward sloping, so it must be positive. Because AC is perpendicular to CD, right? That's the reason why we're saying it's half. Now, the point that occurs here, we find the gradient of AC. Now we have a point on AC, which is 1 and -2. So y minus y1, what's y1? -2 equals m, which is half, into x minus x1, which is 1, equation of the line. So remember, you have a plus 2 here. Take it over, it will become minus 2. This is plus 2. Take it over, you get minus 2, which is half x minus a half. So y is equal to half x minus 5 over 2. And so I have an equation of AC. Right, so that's what they wanted. Write the equation in the form y equals mx plus c. Coordinates of E. What is the coordinate of E? Coordinate of E will be easy because it's just basic midpoints, right? So we're going to call E as x2, y2. So to find the coordinates of E, we're going to say x2 plus the endpoint. The endpoints, remember, these are midpoints, equal radii, isn't? So we will say x2 plus 1 divided by 2 is equal to 3, and y2 plus minus 2 divided by 2 is equal to negative 6. So let's see, 2 times 3 is 6. So x2 is equal to 5. 2 times negative 6 is negative 12. Y2 minus 2. So y2 is now equal to negative 12. So that's negative 10, right? So that's what we have. 5 and negative 10. So that's my coordinates of E. Okay, 5 and negative 10. Uh, A, C, E. A is 5, 0. Does this say that the circle is passing through points A, C, and E? A, C, and E in the form. They gave us a point which is 5, 0. A is 5 and 0. Yes, I'm gonna translate this thing. Sorry. Okay, that's what it says. So determine the equation of the circle passing through the points A, C, and E. Determine the equation of a circle passing through the points A, C, and E in the form. Why did they tell us to find the equation of the circle passing through A, C, and E? It's a very interesting problem, right? And something for you to think about. Why would they say to find the equation of the circle passing through A, C, and E? And I like this question, the way they have answered it. They asked this question. Find the equation of the circle passing through ACE. So the coordinates of A is given, which is 5 and 0, right? E is 5 and negative 10, right? Why would they say to find the equation of the circle passing through ACE? Remember, this angle C is 90. So if I try to draw a circle, Right, so I drew a circle around ACE. Now what? I've got 3 points on the circumference, right? A, C, and E. So obviously I can't join these two lines. That's already a chord. That's already a chord. The only option I have is to join AE. Okay. Now if I join AE, see what AE becomes now. If I join the line AE, AE now becomes the diameter. Why? Why is it a diameter? Because you got 90 degrees converse angles in a semicircle, right? So we can say AE is a diameter because converse angles in semicircle, right? So that is sorted. Now, what is the distance AE? What is distance AE? We can find that because that's going to give us the diameter. And to find the center, we're just going to find the midpoint. So we say AE is equal to 5 minus 5. Oh, by the way, that was just a vertical line. I don't know why I drew it slant. This would have just been a vertical line. Yeah. Oh, that's nice because if it's just a vertical line, that will also be, because this is 5 and that point is also 5, this has to be a vertical line. So this is also 5, right? And if you're finding the midpoint will be minus 5 because 0 and minus 10. Anyways, I already have the center and the radius will just be 5 as well, isn't? Because I'm just going from there to there. Yeah. So let's see. Minus 10 minus 0. So the square root of 100, which is 10. So the radius, 10 is the diameter. Radius is equal to 5. 10 divided by 2, which is the radius. The entire distance AE is 10. Radius is 5. What's the midpoint? The midpoint is 5 and negative 5. Now you can write down the equation of the circle in that center radius form. So you got x minus 5 all squared plus y plus 5 all squared is equal to 5 squared, which is 25. Nice question, guys. So nice this question was. Thinking, little bit of thinking, and it was 5 marks. I'm going to do the same here. I need to translate this as well. Right, so this is 4.7, the last question on this, right? And it was 4 marks, right? A circle with center D with equation must intersect the circle with center O twice. All right, calculate the possible values of R. All right, so now I like this question, and it's exactly what we need to do. So you're just talking about those two circles, all right? They got nothing to do with the previous circle there, right? So let's see. If a circle with center D is circle with center D, which is T and negative 6, right? So that's the reason why we got this equation here, x minus 3 all squared, because remember the value of t was 3, minus 6 must intersect the circle with center O twice. Calculate the possible values of R. Now, remember what you need to do is what this question is telling us to do is you have a circle center D, right? And it's like doing this, it's just moving a little bit up, okay? The circle is just moving a little bit up, okay? In other words, you are kind of increasing, what are we doing with the radius then? Okay, so we're not moving that. So what we're doing with the circle is we just expanding the radius. As you expand the radius, you can see it's cutting twice, okay? So we know the radius needs to be bigger than CD. So let's see. What's the equation of the circle with center O? Was that equation given? No. The equation with circle center O wasn't given, but we can find it because remember the distance OC is the radius. Center O. What is the radius of the equation with center O, right? So what's the equation of the circle with center O? So that's x minus 0 squared. Sorry, not x minus 0. I'm finding the radius, okay? I already know the center O. Let's call it C1 is 0, 0, and the radius is 1 minus 0 squared plus minus 2 minus 0 squared. You don't need to put the minus 0. I'm just putting it there so you don't forget, right? And that is just square root of 5. Right? So that's the radius of the smaller circle, which is square root of 5. Now, center C2 is basically, well, that actually has a center, which is O. And center D is 3 and negative 6, right? And capital R is unknown. Capital R, this small r is here, right? Uh, this capital R is actually small r. So let me change the, call it R1, R2. This will be the smaller radius, and this will be the bigger radius. So let's call this R. R1 means the bigger radius, okay? So that's basically just R from here, okay? Now, if you're finding the distance between the centers, remember what's the distance between the centers? OD. OD is the distance between the centers, and that is equal to uh, 3 minus 0 squared plus minus 6 minus 0 squared, which is square root of 9 plus 36, which is square root of 45. So it must intersect the, this bigger circle must intersect the smaller circle, right? So remember, if it intersects, we need three different quantities. We also need R minus R, right? We need the small r. No, this is the big R, right? That's the big radius. R minus root 5 must be between, R minus root 5 must be between OD. Let me write it like this so you don't forget. Let's write down the rule. It's like capital R minus R and R plus R. So capital R is basically R, is from that equation. See, they didn't give us, they just said that is small r, right? And the small r is actually root 5, R2. And what is OD? Square root of 45. What is square root of 45? 9 times 5, so 3 root 5. 3 root 5 and less than R2 is root 5. Now we need to solve this equation, all right? Because we need to solve for R. See, we have this inequality. We need to solve for R. So we need to split up the inequality and solve. So let's solve this side and then that side. So R is less than, I take this root 5 over 4 root 5 and R is here, right? Uh, 3 root 5 minus 5 is 2 root 5. So basically the value of R must be between 2 root 5 and 4 root 5. This here is saying R must be greater than 2 root 5 and this part of here is saying R must be less than 4 root 5. Right, so basically between 2 root 5 and 4 root 5. You kind of need to combine the inequalities. And now if this happens, if the value is between 2 root 5 and 4 root 5, then the circles will intersect at 2 points. Okay, guys, that's it. Calculate all the possible values of R. So the values of R must be between 2 root 5 and 4 root 5. All right, so moving on to the next question. Look at KZN. Okay, this is a nice question, and we'll end off here after this. Let's see. The previous question was in MP. Yeah, it was in Pumalanga paper. This is KZN. Trials 25. This was MP. Right? And yeah, that's solved. So the diagram below shows two circles touching at J, which is 2 and -1. The two circles are touching at J. Okay, great. The smaller circles has its center at the origin. Okay, and the bigger circle has center K, which is A and -3. Now again, OJK is a straight line because they are touching at a single point. The length of the radius of the bigger circle is twice the length of the radius of the smaller circle. So R and 2R, I will fill that in. SR is a tangent to both circles. SR is a tangent to both circles, okay? If SR is a tangent to both circles, remember we can do a radius perpendicular to tangent. We can draw this line here, and we can draw that line there. Remember they are perpendicular. If they are perpendicular, they can be parallel as well, okay? And guess what? If the lines are parallel, we can kind of like use the prop theorem, isn't? So remember, when you're doing analytical geometry with circles, it doesn't mean that you can't use your geometric reasoning. You can always use your geometric reasoning. You can actually use all your maths everywhere here. KO and SR are both produced to intersect at point P. All right, so they're just intersecting at point P. So remember equation of this line and equation of this line. All right, let's solve. Calculate the length of the radius of the smaller circle. Calculate the length of the radius of the smaller circle. To find the length of the radius is easy because that is just OJ, right? The first question is just OJ, which is equals to R, and the length of the radius of the smaller circle is 2 minus 0, so 2 squared plus -1 squared, which is root 5. So if this is root 5, that's 2 root 5. Okay, so remember, I put R and 2R. So smaller circle, that's fine. Number 2, show that A equals 6. Again, OJ and K lie on the same straight line. Okay. So gradient of OJ is equal to the gradient of OJ is equal to the gradient of JK because of collinear points. So what's the gradient of OJ? -1 minus 0, -1 minus 0 divided by 2 minus 0. And the gradient of JK is -3 plus 1 divided by A minus 2. Why plus 1? Because minus minus 1. Now on this side I have -12, and on this side I have -2 over A minus 2. Right, so I can throw the negative away on both sides, cancel the negatives out. So we got A minus 2 is equal to 2 times 2, which is 4. So the value of A is 6. So we showed that the value of A is equal to 6. Right, sorted. So I'll put that the value of A is 6. They want the equation of the bigger circle now, right? That's easy because we have the center and we have the radius, okay? Equation of the bigger circle is easy. Using this diagram, let's switch it around. What's the equation of the bigger circle? We have a center and we have a radius. So it's easy to find the equation of the bigger circle. Now, how are we going to find it? The center is 6 and -3. And the radius is 2 root 5. Because remember, small r was root 5. So this radius will become 2 root 5. So let's just change it a bit. Let's just say root 5 and thus 2 root 5. Now, 2 root 5 is the same thing as saying 4 times 5, root 20. Okay? I just took the 2 inside the third. So you know the equation of the circle, x minus a all squared plus y minus b all squared is equal to r squared. That's what we are doing. So x minus 6 all squared plus y plus 3 all squared is equal to r squared, which is root 20 squared, which is 20. So that's the equation of the bigger circle. Determine the equation of the bigger circle. So this is done. Try to write it in center radius form, unless it's 4 marks, that you will expand the whole thing and write it in the standard form. Does the point 10 and -4 lie outside, inside, or on the bigger circle? Now it's important, this question here, just say the point is 10 and 4. So obviously, if we get an answer of -4 by substituting inside the equation of the circle, so we're looking at the left-hand side, we will substitute 10 and -4. So we'll take 10 and -4, and we will substitute into this equation. X value is 10, so 10 minus 6 all squared. Where did I substitute the 10? In the place of x. plus y is -4 plus 3 squared. So where did I substitute the -4? In the place of y. Now simplify. 10 minus 6 is 4. 4 squared is 16 plus -4 plus 3. -4 plus 3 is -1 and squared is 1. So what are we getting? We're getting 17. You can clearly see 17 is less than 20, right? So 17 is like your r squared. So it's 17 is less than 20. So it lies on the inside, lies on the inside. Okay. Now, if it was, note, if a point you substituted x and y is greater than r squared, sorry, if it is less than r squared, right? If it's less than r squared, then it's inside, right? It's on the inside. If the point you substituted is equal to r squared, right? Then it is on the circle, on the circumference of the circle, on the circle, right? And if it's greater than r squared, the point that you are substituting, right? Then is outside. In other words, the point is outside the circle, outside the circle, right? Those are the key concepts. All right, next question. Calculate the length of PS, the distance PS. Interesting, 5 marks. Now, how are we going to find the distance PS? All right, guys, so we got 2 root 5 here, and we got 2 root 5 here as well. Try to fill in enough information because those are equal radii. I will start by writing OR is perpendicular to PR, PS, radius perpendicular to tangent. Obviously, I need to write something. Then KS is perpendicular to PS, because also a radius perpendicular to tangent. Okay, now how will this help us? You got a 90, you got a 90, you got parallel lines. You got 2 root 5, you got root 5. Did they say O is a midpoint anyway? We need to read the story. The length of the radius of the bigger circle is twice the length of the radius of the smaller circle. Yeah, they didn't say that that's a midpoint, so you can't use the midpoint theorem. Now remember, this was root 5. So now this is also root 5. See this OR, that's also root 5, and this is also 2 root 5. Okay, so we filled in all the information. What's the best way of solving this problem now? We want the coordinates of point P. calculate, no, sorry, we want the length of PS, the distance PS. Can we go and find the distance PS? Using the proportionality theorem I was thinking about. Remember, we can use similarity. Possible to use similarity because remember the top triangle is similar to the bottom triangle. Why? Because we got the case of angle, angle, angle. See, angle P, angle R, angle O. Those are corresponding. Those are corresponding. Those are angles, angle, angle. And I think we have done similarity in grade 9 because I'm not really proving it. I can just say triangle POR is similar to triangle PKS. Right, so uh, they are similar because of angle, angle, angle. Uh, Man, we should have just wrote down the thing. Yeah, it's fine. Write down the three reasons. One is angle R1 is equal to angle S1 because why is angle R1 equals to S1 proven above? The second part is just in case if you want to know how I got the similarity part. Second part is we have angle K is equal to angle O1. Call it angle O1 there. Angle K1 is equal to angle O1. I still need to prove parallel lines to say that now. K1 and O1. This implies we can say OR is parallel to SK because corresponding angles equal. All right, so now angle K1 is because of corresponding angles, because OR is parallel to SK. That's what I'm saying. Now, the last one is we can say that angle P is common. Angle P is common. Right, so angle P is common. So those are your three similarity proof. That's why we got angle, angle, angle. So in triangle POR and triangle PKS. So those are my three reasons why it is similar. But now, will the similarity help me? I have SK. What I want to find? I want to find PS. I want to find PS. I have SK. So we can use PR. What is PR? PR is unknown. And PR is unknown. So will that help us? Man, there was an easier way of doing it, but it's fine. I'll show you the second method. We could have found the equation of Kp and found the equation of, but will that help us? One second. That's root 5. That's root 5. 90, 90. One second. All right, so we're saying PS. So PS is our unknown, and what we're getting POR, PKS. POR and PKS. That's the order of the triangle. That's fine. This piece is missing here. There are pieces missing. I'm stuck with the similarity now because we got. Let's write down what we have. We have KS and we have OR. So I'm going to be stuck with PR. I don't have PR. The distance PR, I don't have. Guys, any other way to solve this? We got 2 root 5. If I can get the distance P to K, then I'm sorted. To get the distance from P to K, then I will be sorted. In other words, I need the distance, I need the coordinates of P. Similarity is just getting me stuck. We have OR. We need PR. Ah, man, this is the midpoint theorem. What are we thinking here? This is the midpoint theorem. I'll tell you why. Why is this the midpoint theorem? Because, you see, this is root 5 and that's 2 root 5. Look at this triangle. Come on, guys. Look at this triangle here. Look at this triangle. This is root 5 and that's 2 root 5. It's like x and 2x. So you can say, right, so we're not going to prove it like this with similarity. I'm going to take this out because we're getting stuck with similarity. So what we're going to say is OR is equal to, yeah, we know that OR is, no, we have to say this. We have to say OR is parallel to SK. So that's the only thing I'm taking out from there. Uh, corresponding angles equal, because we said before that OR, and we know that OR is equal to half, OR is equal to half SK, right? So this implies that O is a midpoint. O and R are midpoints. So what we can say is that PO is equal to OK. PO is equal to OK and PR is equal to RS. And what's the reason for this? Midpoint theorem. Okay? Midpoint theorem because OR is parallel to SK. Question is, but we don't know what is PO, so how can you say that is the midpoint? We are saying that's a midpoint because the center is half the side. See, OR, and you got SK, which is 2 root 5. So RO has to go through the center. That's the reason I'm using. This is also root 5. Distance from there to there is also root 5. There should be another way. All right. I think there is a trig way. I will try that out after I'm done with this. Anyways, so now we can say, so this, we have a triangle over here. So we got PK, which is 6 root 5, and we got 2 root 5. Okay. We got 6 root 5, 2 root 5. So PS is equal to, remember, we have a triangle like this now. and that's PS. So remember that was the midpoint there, right? So that was 3 root 5. So, and this is 3 root 5, right? And this is 2 root 5 and this root 5. Now, see this piece over here. That's 2 root 5. So we can find PS. We can say PS squared or PS is equal to square root of 6 root 5 squared minus 2 root 5 squared. And that's from Pythagoras. So 6 root 5 is 36 times 5 minus 2 root 5 is 4 times 5. Okay. Uh, 36 times 5 minus 4 times 5. That's, let's see, 180 minus minus 20. That's 160, all right? Can we put this in terms of root 5? I can't. Square root of 16 is 4 root 10. Okay, I'm getting 4 root 10. 4 root 10. Yeah, so that'll be 2 root 10 and 2 root 10, 4 root 10. That's what I'm getting here. This was a good try. I wouldn't take this out. I'm sure you can expand on that knowledge. And I'll just put an asterisk here. But the other way that would have worked is finding the equation of PK, right? And finding the equation of PS, intersecting both of them and finding that coordinate there. And then using that coordinate to find PK, the distance PK. I think that would have been more appropriate instead of using this midpoint theorem here. This supposed to be a midpoint and that's supposed to be a midpoint in order for us to use this theorem here. I want to double check, right? And see if this will actually work in your case. Uh-huh. Guys, I'm not done with this question. It's a little bit challenging. Just be with me. Let's look at an alternative scenario. So we got the answer for PS, which is 4 root 10. Let's look at another way, right? Right, so we got this coordinate over here. Let's find the equation of the line PK. Equation of the line PK. So we know the gradient of OR is equal to negative half. I think that's what we had. The gradient of OR is negative half. Let's see. Didn't we find the gradient of OR? Yeah, the gradient of OJ, sorry. The gradient of OJ, why am I saying OR? The gradient of OJ is negative half, right? And we have a point and it's going through the point J, right? So we can find the equation of PK. Equation, right? Equation of OJ. Remember J is a point 2 and negative 1. So y is equal to, well, the y-intercept is 0. So y is just equal to negative half x, right? So that's the equation of PK. Now, we have, in this case, we have RS. We have the point K and we have the point S here. How is that helpful? If I want to go and find the equation of PS, equation of the line PS, how would I find that? Because I don't have a gradient going on this direction. I have nothing going there. Is the equation of the circle given here? If the equation of this circle is given, the equation of this circle is given here, then I can find the coordinates S. Will finding the coordinate S help me out? No, no ways. One second, guys. One second. One second. Calculate the length of PS. I hope this answer is correct. Just looking at an alternative way of finding the length of PS. PS over PR is equal to PO over PK. The triangle is 90 degrees. Okay. Let me try this way, guys. Watch here. Uh, Look at this. This is a 90-degree triangle, and that's a 90-degree triangle. That's a root 5 as well. And this is 2 root 5. Let me try to put an angle theta here, okay? And so let angle P equal to theta. Finding another way. I can't go anywhere with this. Y equals negative half x. So this is not helping me. I'll just block this out. Just an idea that I used. Now, try to find tan theta. Tan theta is OR over PR, right? Opposite over adjacent in the in triangle POR. This is in triangle POR. That's what you're looking at, OR over PR. So tan theta, what's OR? OR is root 5 and PR is just PR, okay? And try to find tan theta from the second triangle. In triangle EKS, tan theta is opposite over adjacent. So opposite is KS over PS. KS is 2 root 5 over PS. That's tan theta. So now I can equate both the tan thetas here because they obviously tan thetas are actually equivalent. So you got PR and PS. Again, I'm circling back to the midpoint theorem again. Right, so obviously I can take out the root 5s. PS. Okay, we're gonna flip both the fraction. So we're gonna say PS root 5 is equal to 2 root 5 PR. Then I can take out the root 5s on both sides. So PS is equal to twice PR. PS is equal to twice PR. Great. So we just proved that it is a midpoint. So I'm sure you can use that above thing. We just proved that PS is equal to twice PR. So those are midpoints. Now, because you have proved that it's midpoints, you can actually solve it. That. So I would suggest do this first, prove that PS is equal to 2PR, and then use this information over here. So what we did above was correct. I just want to confirm, I was just confused. All right, last question. At this, oh, this is going to be a thinking question because it's 7 marks. Right. The length of the diameter of the equation, the length of the diameter of the circle with equation is 24. The diameter of the circle equation is 24. Determine the coordinates of the center of the circle. The length of the diameter of the circle with equation is 24. Determine the coordinates of the center of the circle. Right, so we want to find the center of the circle here, all right? Uh, so part one, x squared minus 4x plus minus 4 over 2 squared plus y squared plus 5y plus 5 over 2 squared is equal to negative d. Now be careful what you're writing. That d doesn't represent the diameter. The d is part of the equation of the circle there, right? This d over here. So you need to say plus. Now remember, instead of writing that whole thing squared on the other side, I don't want to square the whole thing. I'm just going to say plus 4 plus 25 over 4, right? Minus d. Oh, by the way, this is an independent question, got nothing to do with this, right? With this diagram. Minus d, did I do this right? Minus 4 divided by 2 is minus 2 squared is 4 and 25 over 4. That's correct. Now, the center will be x minus 2 all squared plus y plus 5 over 2 all squared is equal to negative d. Now remember, 4 can be transformed as 16 over 4, right? So I'm making LCD. So 16 plus 25 is going to give me 39 over 4, okay? 4 plus 25 over 4. 16, 41, 41. 16 plus 25 is 41. Right, so that's 41 over 4. So what's the center of the circle? The center is 2 and negative 5 over 2. So from there, opposite sign, opposite sign. Now, see what they said, the diameter is 24. Now remember, this entire thing over here is r squared, okay? R squared is equal to 41 over 4 minus d, or minus d plus 41 over 4. That's what r squared is. But now the r is 24 divided by 2, which is 12. Okay? R is 12. So you need to say 12 squared here. So r is 12. So you're getting actually 12 squared, which is equals to negative d plus 41 over 4. Now 12 squared is 144, right? Which is negative d plus 41 over 4. So take the d over and take this 141, 144, bring it to the other side. So 41 over 4 minus 144 over 1. So you got 41 minus 144 times 4. Yeah. Anyone, what's 144 times 4? 17 there. 576, all right? And that's your answer. 41 minus 576 divided by 4. Just check that up. So the value of 4 is minus 535. Okay. The value of D is minus 535 divided by 4. That's what the value of D is, because That's what they want. The coordinates of the center. So basically, this entire question was just completing this. You just needed to understand the second part of here because that is r squared. And they told us the diameter is 24, so the radius has to be 12. So 12 squared is 144. Then I can solve for d here, bring the d over, 144 over to the other side. 41 over 4 minus 144. That's 576 divided by 4. Yes. Yeah, we are good. That's it, guys. It's end of.